Right, the last part of this projectile revision podcast is just about maximum range. You get a maximum range whenever you have your projectile being fired at 45 degrees. And so that gives you a maximum range. And sometimes you'll be asked a question about that. There is a formula which we can use to calculate the range of a projectile, and that's the velocity squared times the sine of 2 theta, and it's over the value of g, and that gives you this range here. And so obviously the range is going to be maximum whenever you have theta 45 degrees, the sine of 2 theta, which will be 90, the sine of 2 theta is going to be 1. Any other value of theta, the sine of it's going to be less than 1. So therefore you're going to get your maximum value of r when the sine of this is the sine of 90. And so that's why theta is 45 degrees. Now sometimes you might be asked, you're given a value of theta and you're told that there's another angle at which your object can be fired, which will give you the same range. So if I draw two different vectors there will be two vectors which will give you two different angles, theta, and we'll call the second one theta 2, theta 1, theta 2, and they will give you the same range. Now they'll be like that there. So how would you work out what a second angle was? Well, if you use that equation there, r is equal to v squared, the sine of 2 theta, over g. And you rearrange that rg over v squared gives you the sine of 2 theta. Now you have to think about, whenever you get this value, you have to think about we'll find 2 theta first. 2 theta is equal to the inverse sine of rg over v squared. So I'm going to give you an example. Say 2 theta comes out to be 70 degrees. You have to think from maths. If the inverse sine of an angle is coming out as a positive value, you should remember from maths, from your quadrant idea there, that either you could find your 70 degrees in here, or you could find your 70 degrees in here. So that could be 70, or this could be 70. So that means that your 2 theta is not just equal to 70, it's also equal to 180 minus 70, which is 110 degrees. Now, obviously, you can't fire a projectile at 110 degrees because you'd be throwing it over your back and it wouldn't go this way. And so therefore, that's the 2 theta value is 110 degrees. So theta, if you divide those by 2, must be either 35 or 55 degrees. And therefore, these two angles here are 35 or 55 degrees. And they will give you the same range. And therefore, they must also take the same time. Even though this one travels higher, but you have to remember that it's been shot at a different angle, and so therefore they must take the same time to land if they're shot at the same speed with a different angle.